I take a simple example of, for example, if we have blue water, say ink, and white water, that's water without ink, in a tank with a little separation, and pull out the separation very delicately, then it starts separate, blue on one side, white on the other side. Wait a while. Gradually the blue mixes up with the white, and after a while the water is Luke blue. I mean, it's sort of 50-50, a color uniformly distributed throughout. Now if we wait for a long time and watch this for a long time, it does not by itself separate. Or you can do something, you can get the blue separated again. You can evaporate the water and condense it somewhere else and collect the blue dye and dissolve it in half the water and put back this thing and so on. While you're doing all that, however, you yourself are causing irreversible phenomena somewhere else. So by itself, it doesn't go the other way, and that gives us some clue. Let's look at the molecule. Suppose that we took a moving picture of the water, of the blue and the white water mixing. It would look funny if we ran it backwards, because we'd start with uniform water and gradually the thing would separate and would be obviously nutty. Now we magnify the picture so that every physicist can watch atom by atom to find out what happened irreversibly, where the laws of balance of forward and backward broke down. And so you start and you look at the picture and you have blue atoms. That's ridiculous, but we'll call it that. We have atoms of one kind and atoms of another kind jiggling all the time in thermal motion, wiggling, bouncing. And if we were to start at the beginning, we would have mostly atoms of one kind on one side and atoms on the other kind on the other side. Now these atoms are jiggling around. It's too small a box. You need more to get this effect. Billions and billions of these atoms. Now these atoms are jiggling around. I just put one more, but I'm getting tired of making it clear. Now these atoms are jiggling around, and if we start all on one side and all on the other, we see, of course, that in their perpetual irregular motions, they'll get mixed up. And that's why it gets to be more or less uniformly blue. But let's watch any one collision. Here's a particular collision selected from that picture. Here's this molecule moving this way and this one moving this way, and they come together, say, in the moving picture, and they bounce off this way. Now you run that section of the film backwards, and you find a pair of molecules moving this way, bouncing off that way. And the physicist looks with his keen eye and measures everything and says, that's all right, that's according to the laws of physics. If two molecules came this way, they would bounce that way, and if they came that way, they would bounce this way. It's reversible according... The laws of molecular collision are reversible. So if you watch too carefully, you can't understand it at all. Because every one of the collisions is absolutely reversible, and yet the whole moving picture shows something absurd, which is that the molecules start in the reverse picture. The molecules start in this condition, blue, white, and blue, white, and so on, all mixed up. And as time goes on, through all the collisions, the blues separate from the whites. And they can't do that. But that's not natural, that the accidents of life will be such that the blues will separate themselves from the whites. Yet, if you watch this reverse movie very carefully, every collision is okay. Well, you see that all there is to it, that the irreversibility is caused by the general accidents of life. That if you start with a thing that's separated like this and just make irregular changes, it gets more uniform. But if you start with something that's uniform and make irregular changes, it doesn't get separated. It could get separated. It's not against the laws of physics that these things bounce around so that they separate. It's just unlikely. It never happened in a million years. And that's the answer. The things are irreversible only in the sense that going one way is likely to go, but going the other way, although is possible and is according to the laws of physics, wouldn't happen in a million years. It's just ridiculous to expect that if you sit there long enough, the jiggling of the atoms will separate a uniform mixture of ink and water into ink on one side and water on the other. Now, if I had put a box around here so that this was all the molecules that there were, as time went on, they would get mixed up. But if you're patient, I think you could believe that in the perpetual irregular collisions of these molecules, after some time, not necessarily a million years, maybe only a year, so you keep watching, accidentally they get back more or less like this. In the sense, at least, they get back far enough to say that if I drew a line through all the whites on one side and all the blues on the other. It's not impossible. However, the actual objects with which we work have not only 4 or 5 blues and whites, but they have 4 or 5 million atoms. And it's just not likely that 4 or 5 million are all going to get separated like this. And so the apparent irreversibility of nature does not come from the irreversibility of the fundamental physical laws. It comes from the characteristic that if we start with an ordered system and have the irregularities of nature bouncing, then the thing goes one way.